Alrighty, this is time for a quick review of Chapter 4X, going off the grid. Okay, so in the idea we are looking at EMR, electromagnetic radiation. In other words, we're looking at energy. Now, the thing about energy is, ladies and gentlemen, that we have something called wavelength. Now, with wavelength, that is typically in meters, but they can also be in nanometers, okay, where 1 nanometer is equal to 1 times 10 to the minus 9th meters, okay? Now, some people would say, Mr. Canu, do we have to remember this? No, you don't. I would give you those conversions if you so need this, all right? But wavelength, you should be able to tell me, one, how do you determine wavelength if I give you a wave that looks like this? Hi! Not that kind of wave, this kind of wave. Okay? So when we look at it, this is our wavelength. Okay? Now, we can have long wavelength, we can have short wavelength. Okay? So in this case here, you guys get to see two waves. You get to see a longer wave and a short wave. Think about like clapping your hands. Clap your hands, all you people. Okay. So with that short wavelength, you have something called a frequency, right? That's frequency. Is this annoying you? Okay, I'll stop. So frequency, the idea behind that, ladies and gentlemen, frequency is represented by this funny looking V. And that's called the frequency. In other words, how often does something happen? Okay? You can look at the frequency of how many bad jokes Mr. Canu tells in a period. Or you could look at it as how many waves pass a point per second. And in reality, the unit is known as the hertz, which is equal to 1 per second. Or seconds to the minus 1. These both represent the same thing. They're the hertz. Okay? So when we talk about short wavelength, okay, do we get a high frequency or do we get a low frequency? Well, let's demonstrate. Okay? Here's a long wavelength. I'm not getting that many claps in, certainly not in a second, and I certainly wasn't counting. On the other hand, short wavelength, you get more waves passing a point per second, and as a result, you get a higher frequency. So, now, the big question is, how much energy are we looking at between high frequency and low frequency? Okay, I'll stop. When it's high frequency, you got more waves passing a point in a second, which means you're going to have high energy. On the other hand, if you got not many waves passing through, it's a low frequency. It's like low energy. Frequency low. Low. But if you have shorter wavelengths, you get a higher frequency. And with higher frequency, you get higher energy. See, there is a connection to it. So when you think about the energy, that's great. Now you know about the wavelength, you know about the frequency. But here's the thing though. It's not the entire story, because ladies and gentlemen, there is also something else there is something called the c. That means it is, in fact, the speed of light. Okay? Fastest thing that we know that travels in the universe. Yes, even faster than the announcement for Grandmaster C's latest album release. Absolutely. So this thing is pretty fast. How do we connect all this together? Well, c is equal to our wavelength times our frequency. This is the formula. And some people are asking, Mr. Canu, do we need to memorize the formula? Only if you've been annoying me in class and you know who you are. Hey, it's late at night. I'm tired. I eat at Brandon's Diner, man. Okay. So anyways, this is it right here. This is our basic formula. I'm not going to show you guys how to solve the problem because you guys already know this. Okay? Because you're an owner's kin. You're the elite in training. Okay? But now we got to talk about photons. Now remember, photons are essentially particles that have energy in them. And they can have different amounts of energy. They travel at the same speed, but the wavelength is different, and thus the frequency is different. High frequency, high energy. Low frequency, low energy. So how do we work that? Well, there is energy is equal to, and then there's something called Planck's constant. Yeah, you might remember Planck's constant. Okay, it's got that letter H, and you'd sit there and go, ugh, why do we have to sit there and worry about Planck's constant? Because mathematically we have to, so deal with it. That's all I'm saying, okay? So E is equal to H times our frequency. Not velocity, boys and girls. Not velocity, okay? That's not it. Now, keep in mind, this is also equal to E is equal to H times C over lambda. Okay? Okay? Here, let's make this a little less complicated. Okay? You know what? Now I am getting tired. Anyways, I'm going to leave the formula here. I am giving you guys the formulas tomorrow, guys, so you don't have to worry about it. Those are the formulas you need to be familiar with. I'm not doing the one where the electron jumps 2 levels and it drops down 3. How much energy does it give off? You're not going to have to worry about that, okay? I promise. Unless, of course, you annoy me. Oh my gosh, that'd be fun. Okay? So, that's it, basically, boys and girls. That is it. I am done. I have tried to help you guys out. It will be up on YouTube. So, woohoo! Alright, guys. Take it easy. Don't work too hard. And for all USC fans, just handle it.